Have you ever wondered what the universe is made of? Not just stars and planets, but the very stage on which everything happens? What if I told you that space and time are not separate things, but two parts of a single four-dimensional fabric? This is space-time, and it's one of the most mind-bending and fundamental ideas in all of physics. Stick around and we'll unravel it together.
For centuries, we thought of space and time the way Isaac Newton did. Space was like a giant, unchanging box, a three-dimensional stage where all the events of the universe played out. Time was like a universal clock, ticking at the same rate for everyone, everywhere. They were separate and absolute. A meter was always a meter, and a second was always a second, no matter where you were or how fast you were moving. It's an intuitive idea, but it turns out the universe is much weirder and much more interesting.
In 1905, a young patent clerk named Albert Einstein shattered that old picture with his special theory of relativity. He realized that the speed of light in a vacuum is constant for all observers. This simple fact has a massive consequence. Space and time must be relative. They can stretch and shrink depending on your motion. Einstein showed that space and time are interwoven into a single continuum, space-time. Think of it this way. To pinpoint an event, you need 4 coordinates. 3 to tell you where it is, length, width, and height, and 1 to tell you when it is, time. You can't have one without the other. As Einstein himself wrote in his book, Relativity, the Special and the General Theory, every event is a point in this 4-dimensional space-time continuum.
So if space-time is a thing, what does it do? This is where Einstein's general theory of relativity comes in. He proposed something truly revolutionary. Gravity isn't a force. Instead, mass and energy tell space-time how to curve, and the curvature of space-time tells matter how to move.
Imagine space-time as a giant flat trampoline. If you place a bowling ball, representing the sun, in the middle, it creates a dip. Now, if you roll a small marble, representing the Earth, nearby, it doesn't fall straight toward the bowling ball because of a force. Instead, it follows the curve in the trampoline created by the bowling ball. That's gravity. The Earth is simply following the straightest possible path through the curved space-time around the sun. What we feel as the force of gravity is just us moving through this warped geometry. No one explored the extreme consequences of this idea better than Stephen Hawking. In his legendary book, A Brief History of Time, he explains how massive stars can collapse under their own gravity, curving space-time so intensely that nothing, not even light, can escape. This is a black hole. A black hole is not a cosmic vacuum cleaner. It's a region where space-time is curved to an extreme. At the center is a singularity, a point of infinite density where our current laws of physics break down. This curvature of space-time also leads to other bizarre effects. Gravitational lensing. Light from distant galaxies bends as it passes by massive objects, creating cosmic mirages. Time dilation. Time actually runs slower in stronger gravitational fields. A clock near a black hole would tick much slower than a clock on Earth. Yes, gravity affects time.
So what is space-time? It's the dynamic, 4-dimensional fabric of our universe. It's not just a passive background, but an active player that is shaped by mass and energy, and in turn dictates how everything moves. From the orbit of the Earth to the mind-boggling mystery of black holes, it's all a story written in the geometry of space-time. If you want to dive deeper into these incredible ideas straight from the source, I can't recommend these 2 books enough. Relativity, the Special and the General Theory by Albert Einstein. This is surprisingly accessible and lets you hear the ideas from the man himself. A Brief History of Time by Stephen Hawking, a modern classic that brilliantly explains the cosmos, from the Big Bang to black holes, in the context of space-time.
Thanks for watching. Don't forget to like, subscribe, and hit that bell so you don't miss our next journey into the cosmos. Let me know in the comments what topic you want to see next.